Okay, so page 12. We're not actually going to use that table. We're going to use the table with 2 decimal places to get more accuracy. But let's read the question. The section of highway undergoing roadworks. Speed limit of 80 kilometers an hour has been imposed. Police will use a mobile speed camera to detect the speeds of vehicle passing through the section. An infringement notice will be issued to the driver if their speed limit is detected to be over 80 kilometers an hour, you get an infringement. From the data collected from similar roadworks, it's known the speeds of vehicle are normally distributed with mean mu and standard deviation sigma. So we can represent the speeds of the car going through by a normal distribution with an unknown mean and an unknown standard deviation. We're going to need to calculate the mean and the standard deviation for part A, and it gives us 2 facts that will help us out. So 12.3% of the vehicles have speed more than that. 24.2% have speeds less than that. So let's think about how we can write this mathematically. So the probability, let's let x be the speed, that x is more than 82.64, that probability is equal to 12.3%, which is 0.123 as a decimal. Okay, the second fact, the probability that the speed, which is going to be x here, is less than 75.2 is going to be 0.242. So what's different about this question is that we actually know probabilities, but we don't know the mean and the standard deviation. It's sort of like a working backwards type question. We need to work backwards. All right, the first thing I'm going to do is I'm going to change this to be a less than for the first one. So let's do, that'll be 1 minus p x less than or equal to 82.64 equals to 0.123. And I'm going to rearrange to make that probability the subject. So 1 minus 0.123 equals to p x less than or equal to 82.64. Okay, so that's 0. I think that's 877. Yep. Okay, so now what I'm going to do is I'm going to use the table in reverse. So I want to know, I've got this score, I want to know what Z score that will be in order that the probability of getting that Z score less than that is equal to 0.887. So we're going to use the table in reverse. Okay, let's have a look at, I'm going to show the table here. If you have a look at 0.88877, I've circled it there. Okay, and it's at 1.16. Okay, so that means that from table, a score of 82.64 represents a Z score of 1.16. Okay, now I can use the Z equals X minus mu over sigma formula and get an equation there. 1.16 equals to 82.64 minus mu over sigma. That's one equation with 2 unknowns. I might just times both sides by sigma. 1.16 sigma equals to 82.64 minus mu. That could be my equation 1. I'm going to get a second equation by using the other fact. Okay, so this one's already less than, that's kind of nice. I just need to look up the table. Okay, so from table, I'm looking for a probability of 0.242. So go to my table, 0.242. I've circled it there. It's negative 0.70. So that means the score or speed of 75.2 represents a Z score of negative 0.20. So I'm going to sub that into my formula. We don't know what the mean is. We don't know what the standard deviation is. Negative 0.2 sigma equals to 75.2 minus mu, and that can be equation 2. So I've got two equations, two unknowns I can solve. My first thought is let's eliminate mu. If I minus those equations, I will eliminate the minus mu. So if I do equation 1, take away equation 2, 1.16 sigmas, and then taking away a negative, that'll be plusing. That'll be 1.36 sigmas will be equal to 82.64 minus 75.2, and then divide by 1.36. And you get a standard deviation of 4. Okay. And sub into 2. We'll get that the mean is going to equal to 75.2 and then plus 0.2 times 4. So the mean is it should be 70. Hold on. 0.8. Why have we got a different answer here? Oh, apologies. I made an error here. It wasn't negative 0.2. Let's go back to the table. It was negative 0.7, I think. Let's have a look. Yes, negative 0.7. I misread my writing. So that changes that to that. That changes that to that. That'll change that to an 8.6. The answer is still 4. And then that'll just change this answer to 0.7 there. And that changes the mean to 78. Sorry about that. Okay, fixed it up. So the mean is 78 and the standard deviation is 4. The numbers worked out nicely. Alright, so that's A done. B. Let's read B. A vehicle passes the speed camera. What is the probability that an infringement notice will be issued? Okay, so remember, infringement notice is if we're driving over 80 kilometers an hour. So I want to work out the probability that X is above 80. So for part B, we want the probability that X is greater than 80. We now know the mean and the standard deviation. We can change this to a Z-score problem. So Z equals to X minus mu over sigma. If you put in 80, the mean is 78, the standard deviation is 4. If you put that in there, you get Z as a half. So this question just becomes probability that Z is greater than a half. Okay, or greater than 0.5, which is going to be 1 minus the probability that Z is less than or equal to 0.5. Go to your table. 0.5. There it is. 0.5 is 0.6915. 0.6915. 0.6915. And then you get your answer, which should be 0.3085 or 30.85%. So that's the answer to B. Question gets trickier now. Question's still going. Next page. So we've worked out the standard deviation and mean, which kind of carries through. Let's read. On a certain day, the speed camera is faulty. There's an error detecting the speeds of the vehicle. The error is calculated by doing the speed detected by the camera minus the actual speed, and can be modeled using that probability distribution there, where alpha is a non-zero constant. So basically half the time there's an error of 2, and half the time there's an error of 2 plus alpha. It might be useful to rearrange this equation. If I let E be error, speed detect I'm going to call SDT, and actual speed I'm going to call X. Okay, if you actually rearrange this for the speed detected is the actual speed x plus the error. Okay, so basically this first guy here, error of 2, getting a probability of 0.5. Imagine your actual speed was, if your actual speed was 78 and the error is 2, the speed that the camera actually detects is 80. Okay, so basically the error is how much you're adding on to the actual speed to get the speed detected. So basically this thing's faulty. It's going to pick people going up above 80, but they're not actually going above 80. All right, so find the probability that an infringement notice will be issued. So infringement notice is issued when the speed detected is greater than 80, but the speed of the vehicle, the actual speed of the vehicle, is not over 80. Okay, so and the speed of the vehicle, instead of but I'll put and, but it means the same thing. And the speed of the vehicle is not over 80. So that means and x must be less than 80. For the following cases, when alpha is 1 and when alpha is -3. Alright, so I'm after that the probability that the speed detected, which is x plus my error, I want the x plus the error to be greater than 80 and my x to be less than 80. Okay, so half the time the error is 2, half the time the error is 2 plus alpha. So, and here alpha is 1. Okay, so really this means that half the time the error is 2. And half the time the error is 2 plus 1, which here is alpha, is 3. All right, let's make x the subject in these. So half the time I want to know basically where am I greater than 78 and less than 80. And half the time, where is the probability greater than 77 and less than 80? Okay. And we can combine this. If I'm greater than 78 but less than 80, I can write that as 78 and 80. And this one here is between 77 and 80. All right, we have to convert all the scores involved in the question into Z scores. Okay, so a reminder that the mean was 78 and the standard deviation was 4. We worked that out from part A. So you basically go through and work out, I want to work out probabilities, so I need to work out Z scores for each of those. 78's easy because it's on the mean, it's going to be 0. Okay, so that's going to be 0. 80, we did 80 in the last question. When x is 80, the z is half. Okay, 80 minus 78 on 4, which is a half, or 0.5. 77, when x is 77, 77 minus 78 over 4, that should be negative a quarter, or negative 0.25. So that's what I've got there. Okay, remember if you've got working out the probability between two, you minus, so it's going to be half. I'll put big bracket there, z less than 0.5 minus half, well, probability of z less than 0, plus a half probability z less than 0 minus the probability z is less than negative 0.25. Okay, the zeros are going to be what? It's going to